Hi everybody, thought I'd go over a few problems with U substitution. So I just picked the first three because I thought that that would be a good sampling. So first thing that we talked about was looking for a function within a function to potentially pick as a good U. So I'm seeing that this 4x is inside the sine function. So I'm going to pick that as my U. So I write U equals 4x. And then the next thing that I do is I take the derivative of both sides. So there's a variable mismatch. So the derivative of u is du dx. The derivative of 4x is just 4. And then I can solve both sides for du. So this is kind of the way that we'll start each of these u substitution problems. Is we start like that, and then we look back at the original problem and say, is there a 4 dx in the problem that we want to substitute? And if not, then we can do some rearranging. I see that there's only a dx, not a 4 dx. So I'm going to divide both sides by 4. And then I think it's easier, instead of looking at this as du over 4, I think it's easier to look at it as 1/4 du equals dx. So the u is what I'm going to substitute in for 4x. And then I also have dx is 1/4 du. So now I'm going to go back and rewrite my integral. Integral of sine, and then I see that I highlighted in blue, so I'm going to go to my blue highlighting and see that I'm substituting in u in place of 4x, and then I see that I'm substituting in 1/4 du in place of dx. So I'm going to put the du here, and I'm actually going to put the 1/4 out in front. I can put the 1/4 in front of the integral or inside the integral. It just comes along for the ride, so either way is fine. Then I want to do the integral, so I have to take the antiderivative of sine u, which the derivative of cosine, remember, is negative sine, so the antiderivative of sine is negative cosine. So I'm going to end up with negative 1/4 cosine u plus c. And then my final step is to go back, because I don't want any u's in my final answer, I need to go back and replace the u with 4x. So negative 1/4 cosine 4x plus c is my final answer. It is possible that you could do this one without doing u substitution, because you know that the antiderivative of sine is negative cosine, and because of that 4x, you would know that you would need to multiply by a 1/4. So this is an example where I think the u substitution is probably an optional strategy, and you could have done it a different way as well. Okay, let's take a look at the next one. I am looking at the function that's inside of another function, and I'm going to go with x squared plus 1 as my u. So u equals x squared plus 1. So I take the derivative of both sides, so du dx equals 2x. And then I solve for du by multiplying both sides by dx. So du equals 2x dx. Then I look back at the original problem, and I see that I just need a dx, not a 2x dx. And I think about, well, I could divide both sides by 2x, but then all of a sudden I have du's with my x's, and that actually seems more complicated. So this one to me actually seemed like it's not a good candidate for u substitution, and it would be better if I just squared the x squared plus 1 and then took the antiderivative from there. So if I made a little box and did x squared plus 1 times x squared plus 1, I'd get x to the 4th plus 2x squared plus 1. And then I could just use my power rule, where I increase the exponent by 1 and divide by that exponent, increase the exponent by 1, divide by that exponent, and increase the exponent by 1. The exponent's just 1, so I don't really need to divide by it. And then don't forget the plus c. So this was one where u substitution didn't really work, but we could just expand it and use our power rule, and we could still find the antiderivative. Okay, let's do one more. This time when I'm looking for a function inside of a function, I'm seeing cosine of square root of x. So let's give square root of x a try as our u. So I'll take the derivative of each side, du dx, equals, and then I could do the whole turning this into x to the 1/2 and using the power rule, but we do have a poster in class with a little shortcut of that's what the derivative turns out to be. And then I'm going to multiply both sides by dx. du equals 1/2 root x dx. So I look back at my original problem, and I do have a root x in the denominator. which is great, but I don't have a 2. So I'm going to multiply both sides by 2 so that I can cancel that 2 out. So I'm going to have 2 du equals 1 over root x dx. And that might be hard to see, but I'm going to put in an imaginary 1 here. And then let me highlight that there is actually a 1 over root x dx in the original problem. It's just, I find it's a little harder to see when what you're substituting is in the denominator. So I'm going to rewrite my integral as cosine of the root x was my u. So cosine of u. And then 1 over root x dx I can substitute with 2 du. So I'm going to put the 2 in front and then du. And then now I'm ready to integrate. So I'm going to take the antiderivative of cosine, which is sine. So I'm going to go 2 sine u plus c. And then my final step is I don't want the u in my final answer, so I'm going to replace it with root x. And that's my final answer. So hopefully this helps you start thinking about u substitution. If you have any requests for other problems that you want me to go over, let me know, and I'll see you in class.